out. Very often we are not getting the key information that we need to measure it the way we want it. So how do we change this? What are the main things? So communication with the design team early in the process is the most important part. I can't stress enough how little information you're going to get the way you want it if you are looking at a model at tender stage. It has to be before the model is produced is when you need to communicate with the design team. So when the EIR or your BIM execution plan is being drawn up and prepared, usually by the architect, that is when you need to start engaging with the architect on the model. So before it's ever even started. And I suppose for us, some of the key points in that would be like what file format. Like these are simple requests. What file format can you open? For us in our office at the moment, IFC is the main file format that we work for, and that's international. And every architect or engineer or M&E consultant should be able to give you an IFC. If they tell you it can't be exported or it takes a long time and all the rest of it, that's rubbish. It doesn't take a long time, not unless they're using Windows 98. So it can be exported into IFC. There are correct ways in doing that. And when you get familiar with the practice of doing it, then you'll get better. And in KSN, we have a document that we give to the architect as part of their preparation, which is the key items we need out of it. And one of the things we will always reference is building smart. So model-based quantities and definition of base quantities. And this is a very, very simple document. And it outlines what are the base quantities that need to be in the model for us to measure a beam or a column or a steel member. And this is critical really in getting out the key high-level quantities out of your BIM model. The next thing that needs to be set out in the BIM execution plan or even in the EIR is what way does the client need the information? So let's say you have a commercial development and it's split into basement, car parking, retail, commercial office and residential. And all of these different sections you need to split out the cost. It is no good to you if the engineer has one single beam running from the top of the foundation pile cap up through the basement, up through the retail space, up through the commercial office and up through the residential. That is no good to you. You can't use that information. But if you set this out early days before the architect and the engineer start into their model, it's very easy for them to split it out. If you ask for it at tender stage when pressure is on, you won't get it. So simple requests early are the key in getting a model that you can use. So yeah, I've touched on it here. So breaking out different areas. What you don't want is hatching done after. This you get a PDF and it's hatched like this. It's of no real benefit to you. The zones need to be measured separately and clearly defined in the model from the start. Otherwise, you're not going to be able to generate the schedules or extract the quantities and clearly define where they are, which is what the whole speed and the advantage of quantity extraction is. And I might just touch on quantity or 3D takeoff and quantity extraction now in a minute as well. So again, I've alluded to this a second ago. This is an example here of we have our basement structure at this level here where we have this red broken line. The engineer has gone and designed the basement or designed his model. And you can see this wall here at the edge is spanning between the top of the ground beam here right up to the first floor transfer slab here on this corner. So what does that mean? It means when I go to extract this wall and add it to my quantity. For basement walls, I can't. It's spanning between two areas. So my area here is 2,372, when in reality, I only want that section there. I don't want all of this. So that's a key point to it there. Like that 70 cubes or that area is of no benefit to me. Not of no benefit to me, but it's not in the way I want it, because I haven't defined at an early stage that I need the basement completely split. And I would also say, very important, if you have a clear definition in your head of where you want it split, aka you want the slab of the lid of the basement as part of the basement, well then that red line goes above the slab, and everyone, architect and engineer, need to be aware of that. And then if you want it below the slab, let's say the slab needs to go in with the commercial, then that needs to be defined early doors. And doing that definition is I think is key to getting the information you want. So ARM4, this is obviously always the biggest stumbling block, and the short answer is it is not easy to extract all the information as you would want it in ARM4. But if you ask for information in a certain way early doors, you can extract a lot more information than you can if you don't set out your requests. So what will happen if, let's say in the morning, I'm doing a 2D takeoff and I'm measuring a slab, I'm not going to measure each section and measure around all the service risers. I'm going to measure the entire gross internal floor area or the outside perimeter of that slab, and then I'm going to go back and measure the service risers and deduct out the ones that are under a certain cross-section area in order to fit into the rules of ARM4. In a similar way, you can get the gross area or the net area of the slab from the BIM model, and then you can get the schedule of service risers, which should be there as well. And you can manipulate the quantity by adding or extracting those service risers from that gross or net area. So no more than we do in 2D. It's the same with 3D. There isn't just one button that just magically dumps out the concrete. No more than I can just measure the concrete and automatically on a PDF drawing automatically have the omissions for the risers. You have to go in and you have to do some work in order to get it. And it's the same thing with a 3D model. You do have to manipulate the information that you get. And again, that's this then leads me on to defining information. So when you start in with the engineer at your feasibility stage, or maybe you're at OMC stage, you're going to get beams that'll be split into concrete or steel. And in the concrete, you're just going to get concrete beams. They're not going to be defined into the different concrete weights. So we need to measure out, if there's a different concrete mix, we need to define that. So it's no good to us if there's a note on the engineer's drawing that says basement concrete is at 55 newtons and all concrete in upper levels is at 40 newtons. We want the concrete to be defined and be given a different type. And if we specify this early, and this is an extraction from our document that goes into the BEP, and we explain how a different specification for us means we need that identified in the right area. And again, all of this information, it's a learning curve. So this is all a learning curve. And every time we extract from a new model, we learn a little bit more. And the key part is, every time we do it, so does the architect and so does the engineer. So the engineer, the next time around, will automatically do this at an early stage. So it means that we don't have to necessarily give them, we might have to give them a prompt on it, but we don't have to chase them for it, or they're not going to complain as much. They'll still complain, but they won't complain as much about having to extract this information. So this is key to it as well. And as I say, it's evolution. So if you've never measured from a model before, you're not going to necessarily go and measure build quantities at the very start. What you're going to do is you're going to maybe take out your key quantities for an ONC or something like that. So you don't have to necessarily get dragged in this level of detail, okay? But as you get more comfortable with the model and as you get more familiar with how the engineer or how the architect is building it, you'll be able to, what did I say, go into the more finer details of reviewing the model and extracting what you need and telling the engineers and the architects what you need, how you need it defined in order for you to meet for requirements. So then, the most important thing is there's so much information in the model. You can always utilize the information in some form or other. As I made the example earlier on, you might get the gross area or the net area of a concrete slab, but that won't necessarily suit HARM4. But you can still utilize the information to check, and then you can add in or extract, let's say, your service rise or plan bookings in order to manipulate to the quantity that you want. And this is a great example here. This is at maybe at the middle stage between, let's say, probably the cost plan stage, where the architect has given us the louver panels on the roof. Now, they're defined at the start as curtain walling, which probably isn't the right category to begin with. So there's a little bit of work in breaking that out. But what they've given us here is just one section, and that includes all the steel posts, etc., all the fixings on the ground. So what can we do with that? Well, we know what the length is and we know what the area is. So if we're doing a cost plan, we can build up a rate for that. Or if we want to go in, we can say, right, there is a post at 3 meter centers. So we can take the quantity back and we go, right, 5 posts plus 1 for the end for each shape. And we can do that at cost plan stage. And what we do at that stage is we extract that information, we manipulate that information to use it, and then we also go back to the architect or the engineer and we say, by the way, thanks for that, but we also need to know what the post is. Is it an SHS? Is it a flange, parallel flange? What is it? What weight is it? We need it separated out from this panel because we can't measure that as a composite item in our final bill of quantities. So you need to give us more information and you need to break this out. So missing information then. So this is one of the key areas. At the start, I was looking at this on Revit, at this model, couldn't find the information. And eventually what I learned was I was in the wrong category. The information was elsewhere. So I was able to find it eventually, but it wasn't designed in such a way by the architect or engineer that when I extracted it to IFC that I could utilize it. So again, it's a learning curve and you realize, okay, I can see a quantity here, but I can't see it when I go to IFC. What's the issue? And after, like everything else, like when I started, we were on takeoff paper and then we were going to 2D measurement, and the first 2D measurement I did was just taken and brought back into BillSoft to form the bill or back into Excel. There was no way we were relying on that 2D software. So like this, you're not going to necessarily be able to rely on this at the start, but you will learn as you go and you'll realize, okay, I need to change my parameters here to get it. And when you engage with the architect and engineer, you very quickly begin to learn how they build different items, and that makes it easier for you then to extract the information. It may not always be missing. It may just be somewhere that you haven't seen before. And again, when you demonstrate to the architect or engineer that, okay, there's something wrong here, I can't find it, and they show you, well, then the next time they'll turn around and go, right, well, if I put it in there, the QS isn't going to find it. So they put it in the correct parameters. So let's say we are getting to the stage of using the model more. We're getting a model that can be used from an architect or an engineer. What do we need to do? Well, we need to validate the model. Validation is the most important part of your model review process. If you don't send out tender drawings without going through a lot of query sheets with the architect. They're never right first day, and you're not going to take a model and rely on the quantities that you get from the architect. No more than an architect isn't going to let a QS build a house. You'll end up with a square box and no windows. You're not going to take quantities from an architect without double checking that they're right. So I just want to define something here for a second, which is measuring from a 3D model, doing takeoff from a 3D model, and then quantity extraction. So if I have a 3D model and I click on the 4 corners of a wall to get the area, that's quantity takeoff from a 3D model, which is just a fancier version of what we do in 2D at the moment. Okay. Quantity extraction is when we take the quantities that are already embedded within the model and we use those quantities. So there is quite a definition there. If you're taking off the 4 points manually off the 3D model, well, then when that model gets updated, you're repeating that process again, or you have to double check it again. If you extract a quantity from a model, when you get an updated model, it'll automatically tell you this has or this hasn't changed. And you can very quickly see, okay, these areas have changed, I need to update it. So there is a big difference there. But when we do extract that information, we can't extract it and assume it is verbatim and no issues with the information. You have to go in and do your spot checks. And I suppose, like everything else, if you let a junior quantity surveyor measure the frame, you're going to do a hell of a lot of checks than if you have an experienced senior quantity surveyor doing it. So if you're working with an architect and it's your first time going through a model, you need to go through that in a lot of detail. You need to check almost every item. And that sounds very tedious. But if you're doing that at the start, you'll pick out the issues early. And then as you move through the process, it's a lot easier. It's very easy to query the planning drawings because you've got a dozen or so drawings. If you're trying to start your query process at tender stage and you've got a pack of 200 drawings, well, then it's a lot more arduous. You still have to do it, but if you've started your queries at an early point and those drawings are coming to you, or that model is coming to you in a fairly good standard, well, then this validation process gets a lot easier. But again, early engagement is the key. If you don't start looking at the model at tender stage, it's too late. You're not going to get these items changed. So I'm just going to explain very quickly here what we have. We have the dimensions, which are the embedded quantities in this case, it was a Revit model. We then have the IFC quantities, which when we converted to IFC and we brought it into our software, this is the information that it gave us out. And then on screen, we have the geometric quantity, which is what our software says. If we look at the volume, this is what we see. So if I can jump back here through the slides for a second, what happened in this instance is this column here, one of these columns is spanning, maybe the other side of the building. One of the columns is spanning the full height. We requested the engineer to issue the model and split it by level. So when he did that, we pulled out this column and we added it to our bill, and we took this column and we added it to another place in the bill. But unfortunately, when he did that, the quantities didn't split. So this was all designed as one column. So it was 10 cubes, when in reality, or maybe it was this one here. So we got this as 10 cubes for these 3 sections. But when he split it by level, these are now all should be 3.7 cubes. But every time we extracted one by one, we got 10.7 cubes at a time. So instead of getting 3.7 cubes for each one, we ended up with 30 cubes for all 3. So again, this is where the validation process is key, and going through that in detail. Now, that incident happened. we picked it up in time because we did the validation process. We've now gone back and working on a new project with the engineer, and he has automatically split the columns in his design process between basement and the upper levels. Now, he hasn't necessarily split it at the upper levels, but he has split it at the basement. So we just need to be very clear when we extract information, where we're extracting it from and where it is on the model. So it's just a learning process, really. So yeah, so I suppose, look, it's as I say, it's evolution. No one's going to take their first model and measure a full bill of quantities off it. You're going to use it day one for maybe double checking quantities, or maybe at the start you're just using the model to view and understand the building. And there's nothing wrong with starting there. You get a bit more familiar with the model, how to navigate around it. The next thing you're doing is maybe checking measurements. You're taking, as I say, you're picking those 2 points on a model, and you're kind of going, right, the height of that upstand is 600 mil. I can't find it in a drawing anywhere. Now I have something to work from for my cost plan. That's great. The next thing is then, okay, checking quantities. Okay, I've extracted all the concrete on the building. It's coming to 10,000 cubes. What's in the model? What does that work out at? Do you know? So you're evolving each time, and every time you do a little bit more in the model, you realize, oh, this is where this is, or that's how I get that off. And eventually then you're doing maybe 3D takeoff, where you're going around and you're taking points off the model and you're adding that to your bill. And your model maybe forms part of your bill quantities. And eventually we're hitting the holy grail. We are extracting quantities from the model, and every time we have a reiteration of the model, we straight away have the quantities to hand, and we can update, we can give cost information back to clients in a matter of hours, rather than having to go through extensive reviews of multiple drawings. We've one model comes in, we can see straight away where the changes are, and we can add that straight away into our Excel or into our BOQ or whatever, and see the impact it has on costs very, very quickly. So again, look, the key things to remember: models are not designed with the QS in mind. However, if we have some early engagement with the design team, we can resolve many of the issues that we face. The earlier we start in the process, the less frustration we will cause with the architect and with the engineer. Again, look, it's, if you turn around to the architect or engineer at tender stage and say, actually, we want to change from RC slabs to precast, you're going to get a fairly frosty reception. If you say this at OMC stage or cost plan stage, they might be marginally more engaging or happy about making that change. So it is key to be in there early doors. It's the exact same thing as you do with your 2D drawings. So again, you need to be part of the process. When the BEP is started, your BIM execution plan is started day one. That's when you need to be engaging with the design team, not after they've already done it and they have started building their models and they don't have the splits in the right place. You can't define the basement from the other areas. You're not getting the IFC model because they've said, look, the BIM execution plan is issued, you're only getting Revit. So that's it. And then be clear on what information you need. Like, as I say, we have a document, and that goes every time we start a new project. First thing that happens is this document goes out to the architect or engineer, and we're like, these are our main parameters. We need to have the quantity extraction, or we need to have the IFC model in order for us to extract quantities. We need these key measurements on a beam or on a slab in order to use the model. So I think that's it for me. I hope that's helpful. And Ross, I'll hand it over to you.
Cool. Thanks very much for that, Aidan. Let me just share my screen here now. So we're going to talk a little bit You're going to have to stop sharing there, so Aidan, and then I'll be able to share. So the pop-up tells me.
Hopefully that stopped there now, Ross. You should be
Nice
able
one.
to.
Spot on, yeah. Hopefully everybody can see that, the digital QS. 2 seconds while I do something here now. Zoom here and get up. Perfect. Thank you very much for that, Aidan. Excellent to get someone else's opinion. And I know we've been in communication now for a few years, but it's really interesting to see your approach to it. And I'm going to kind of build on that slightly, not in the level of detail when it comes to ARM, but more on checking models and the integration process, and then the understanding of the different disciplines actually. And then we'll come back to some questions and answers by the end, hopefully. I know, Jim, you have written something, and we'll get back to that later. But I guess, Aidan, for you, just to confirm what you're saying, you know, the digital QS's BIM world, without integrated collaboration, we cannot succeed. And we keep banging this message home. It's on every presentation that we've been doing for the BIM Bites. We need to get into the conversation. The reason being for this, I would say, if it works, is that in order for us to be able to manage our process through the project lifecycle, we have to get our requirements in early. Now, we'll talk in future presentations, we get into more detail on measurement for the different disciplines, so architecture, construction, and MEP, because they are different. But getting our requirements in early is key in order to be able to get that information out. And the principle here is that if we quantify foundations at an early stage, we should only need to quantify them once, and we should have automatic updates in the preceding stages right up until the bill of quantities. So what happens here is that we're evolving our cost plans into bills of quantities as we develop through the project lifecycle. We're reducing the amount of time that we remeasure, meaning that we have more time in the project for actual advice and quality assurance, et cetera, et cetera. So this is where the real benefit here is for integrating with the design team and using the models. And obviously, we're creating information here, and being able to feed that information into the next projects becomes hugely valuable as well, because we'll become more efficient in our working processes on projects. So what are we gaining here by this? Personally, we think we're gaining time. So as I mentioned, if we're reducing the manual measurement repetitiveness at each of the gateway stages when we prepare our cost plans for the client, and we're focusing on information and data transferable from the models to our cost plans through whatever software we're using, we're not repeating that same manual measurement. Again, I'll use the foundation examples, meaning that we're gaining that time back, and we can invest that time into data qualification, I would say advice and coordination with the teams during the design stages. So what we see here is hugely valuable for the project is that the quantity surveyor, they're the last to review design material before it is released to the client for approval, before it is released to the market for tendering, meaning that we're the last gateway of quality assurance. So kind of looking at what Aidan was describing there, and the discussions that we're having with the design teams mean we're qualifying that information before it goes out, before it goes to the client, meaning that review period, that tender period will be much more smoother because the information is qualified by us, and the contractor will be able to use the model in their process for whatever is necessary during tender stage, let's say 4D in terms of time scheduling. But more importantly, the way we look at it is cost plans and estimates and the bills of quantities are not produced at the end of the design stage. They're produced during the design stage. During the period we are communicating and qualifying the information, we're building on that quality, so that when we get to the end of that design stage, we're just updating, we're not preparing. Meaning again that we're qualifying design information as it happens with the design team. A kind of a byproduct of this process is that you're building trust and relationship with the design team, so that they're coming to you directly if there is challenges, additional scope being added, whatever the case may be. That communication becomes much more fluid with the design team, and it becomes much more collaborative. It means that we're now working together with the design team to deliver a project that's on budget. At inception, we can challenge anything, because really the time and effort put into a project from the design team's perspective is very little. So we can take any avenue available to us in terms of design development. But if we're coming back to the design team at the end of, whichever stage, it could be detailed design, it could be schematic design, and saying, actually, we now need to change all the slabs from in situ to hollow core, or with LCA and carbon coming, we'll be going, actually, we're going to change the entire superstructure to timber. Like, it's way too late in the design, and our design teams are not going to look at us favorably for that. So we need to get into the discussions with them early, in terms of the design development. And for sure, the LCA process is going to drive much more of this as well. So cost plans created during the design process. It's currently how we would operate. This is also quite interesting. The model information and historical information is hugely powerful for us as QSs. So like the digital QS, we can track change visually for our clients so that they can understand what has happened in that design stage. Here is an example. And again, as I mentioned before, we use Costex. This is a Costex visual looking at two different models on the same project. So a model that was previously submitted the previous design stage, and a model that has now been submitted. And we can easily visualize here what has happened on this particular project, and why the ventilation, for example, the budget or the estimate has gone up, because blue matches the previous version, as you can see. Yellow is an element move, so previous version, but we've moved it slightly. Everything else is either added or removed. Red removed, green is added. There's a hell of a lot of green there. And so we're able to visualize that for the client, and it becomes kind of clear to them that it's much more visual to them than numbers. A lot of clients don't understand numbers. Numbers are difficult for people to understand, but visuals like this are super powerful. And we use this in the communication tool, but like communication tool with the client. But like that, we need to make sure that the data has good quality, so we can use it in our process for communication with the design team and also with the client. And so if you're doing your cost estimate and you're discussing with your client that certain areas within the project have gone up because of maybe you're managing the change process, and you can identify them, you can also again show them up in the model if there's a challenge back from the design team that they don't believe that is correct or what have you. The models allow that, because that information you're looking at, that's the design team's information. It's not yours. The cost estimate, the cost plans are yours, but the design information, the models are the design teams. So we're using their information to communicate both horizontally with them, but also vertically up to the client. It's also important to understand that the different disciplines approach modeling differently. Architecture, construction or structures, electrical, mechanical, they design differently in the models. Architecture and structures are element based. What do I mean? What do I mean by that? You have a facade element, and that gets a typical code, description, etc. Structures, columns, beams, slabs, foundations, they're all building components, building elements. But electrical and mechanical are system based. So now the design team need to allocate a component, and that component, let's say a pipe, might be across many different systems within the mechanical design. So they need to now define systems and allocate the component to systems, where the architect and the structural engineer do not. They are only component based. So what happens is, in that communication early, especially with the mechanical especially with ventilation and cooling, where it's systems and subsystems in locations, that needs to be considered very early, so that you, as a cost manager, quantity surveyor, are able to extract the quantum per system, and not just a quantum for the entire ventilation system as a whole, for the entire project. That allows you to get the granularity, etc. And it depends on the method of measurements, of course, and what way you break down your cost. But it is important to highlight here that when we're in this conversation, it's not a generic conversation about the project, especially when we get to the granularity. It's a conversation with each of the disciplines separately, because more than likely they also have different modelers. They come from different organizations potentially. So we need to be clear about that, and also within the BIM execution plan. Yes, as we mentioned before, it's vital to understand the quality and accuracy of the information. Aidan went through a number of areas there in relation to columns within basements versus superstructure. It's also important to understand the quality of the models in relation to that information being provided by, in this example, it's the structural engineer's model. There's beams that are coming out in our quantity extraction, but they're just floating. They're not associated with anything. So they've been modeled or accidentally modeled, or maybe they're come from a legacy model, part of our quantities, but not necessarily part of the project accuracy. So we need to be able to review this information. And I put in the chat, we like to use Celebri on this because we import IFC. As I mentioned before, IFC, we focus on that heavily. We don't actually use Revit, only free Revit viewers online. For any of the QS practices looking to get started on this, we would look at Celebri or even Navisworks, depending on which you prefer, for model viewing, and checking of the data based on the BIM execution plan. So that process should be the design team's kind of control, making sure that what they're giving us is good quality. But like human nature is, we make mistakes, time is against us, we're under pressure, etc., etc. So we try to work with them in order to make sure that we're catching any errors that they send through. Likewise, we would give the design teams our cost plans so that they could look at to make sure we're capturing everything. Transparency, communication it goes both ways. It's not just one directional, because we might have missed something that they're looking at. Let's just keep an eye on my time now as well. So part of the design team, this is what we're reiterating, this integrated collaborative approach. We need to support them so that they can support us. We have to work as a team in this delivery, which is a change in maybe culture within the construction industry. Maybe it's a change within our mindset of how we approach projects and how we communicate. But it's important for us to be able to get the most out of this process. And then, like Aidan, we've some examples here. This is Celebri. We've some examples here of just checking models and having a look at elements and identifying this doesn't look right. For example, this particular one, you can see here on the right-hand side, there's two components, two doors. And why would you have two doors back to back? Maybe it's a requirement, whatever type of project, but it doesn't look right in relation to this project. So we have a query back to the architects on this. Is this correct, or is this some legacy challenge with the design? Can you have a look at this for us? And this coordination from our perspective, we kind of do this weekly or fortnightly with each of the disciplines. 30 minutes, as I mentioned before in some of the other presentations. We just sit with them for 30 minutes, but we get this into the schedule at the very beginning, so everybody knows that this is part of the process, etc. This is not something you do in the design coordination meetings, the large meetings that happen weekly. That's for design teams. That's for them. This is quality of information, and this has got to do quantity output and that qualification. So I would say that we should be taking small bite meetings separately with the disciplines. Here's another example. This is just an extract from a Danish project that we have. On the right here, you'll see all that numbering system. That's a coding structure. It could be uniclass. This is directly out from the BIM model. On the left, it's the specification where the the discipline lead or a designer has specified each of the components. But what you notice is that it's impossible to understand which is which, because this is a legacy numbering system and this is another numbering system. So how do we deal with this within our process of understanding which component in the specification relates to which component in the model? They need to update. These are two different coding structures. So there's an error in that. Now, we caught it as part of our process, but more than likely the design team would have caught it as well. But it's just part of that communication, as I mentioned before. It means we're integrated here, and that visual we use the whole time. It sits in the middle. We're communicating with the design team. Here's another example. It's an output from again, it's in Danish, but it's an output from Solibri, where we have a naming convention and we have a type, yet they're different. So it's confusing when you look at it. So which ones should we take and which ones are incorrect? Again, it's a communication back to the design team. And this particular one, it's concrete tiles. Which sizes are correct here? We need to update this information, because if this goes to the marketplace, out to the contractors, we have a challenge straight away with the contractor coming back with RFIs during the tender period. We don't want that. We want the tender period to be smooth and the information to be clear. That's where we come in to add that quality assurance to the project. And likewise here, we have a radiator defined as a gypsum wall under walls within the model. That's incorrect. And we have the exact same glass walls here with the same DB rating, but two different codes. Why is that different? Are they not the same? And this kind of quality assurance improves the information that we have within the models. And as I say, we can use Solibri for that. Again, you've two different floor types here for underfloor. What's the reason for that? Is there two types in the specification? Can we have a look? Should we see? Is that a challenge for us? More qualification here, as we can see, two foundations on top of each other. Is that correct? Does that make sense? It's just a question back to the structural engineer. Is that correct? If they say yes, then okay, are they two different types? Are they a single type? What way is it defined in the specification? What way is it constructed? And that communication, again, adds that quality to the project. It means that we're clarifying this uncertainty before it goes to the marketplace and before it hits the contractors, because for sure that will come back later at us. Likewise here within this basement, it's the insulation to the external wall of the basement, but it's inside in the structural engineer's model. Is that an architectural element or is it an engineering element? Who defines that insulation, and which model should it sit in, and who should coordinate it? Again, just raising those questions. A lot of the time, if you import the architectural model in IFC, you might get all the structural engineering components, never quantified from the structure from an architectural model, always from the structure. That should all actually be hidden when you extract it, or you shouldn't extract it at all in IFC effectively. So kind of final output of all of this quality assurance, these would be our cost plans, kind of final output from models. You can see the level of information here in the description. Like this is a discussion we were having on Monday in relation to ARM and whether ARM is fit for purpose, and the amount of information you need to transfer from other documents into your bill of quantities, because ARM requires you to transfer the specification type, whatever the case may be. Is that really adding value, or does it create more of a hindrance on the project, because now you've two places in the project telling you potentially the same information, or it could potentially telling you the wrong information. But just to identify here on this cost estimate, everything that has a unit against it here, generally this description is coming directly from the model. We're not typing anything here. This is your code as identified out here. We identify the spec, and this is the description that the design team have written in the model. So we're qualifying that and trying to use what they have described so that we can extract that within the model. And then we would send this to the design team, sometimes with the prices on, sometimes with the prices off, depending on what our contractual relationship is, but we would ask them to qualify their sections. So for example, if it is the electrical engineer and the electrical section, we would send that to the engineer and they would qualify before we would release our document to the client, for example, or before the BOQ would go to the marketplace. Again, it's that collaborative approach, because the engineer knows their project the best. They should know it better than you. You're only the collective information and the restructuring of it. And by doing this communication, as I mentioned before, it creates this collaborative environment between the stakeholders. Yeah. So as Aidan mentioned, don't wait to the end. If we wait to the tender period to start working with models, it's too late. You will never ever get what you need, because design teams are not designing for you. They're designing for themselves. They're designing for drawing outputs. They're designing in accordance with their contract, whatever that may be. They're not designing for quantum output or for quantity surveying cost plan or BOQ production. So we need to bear that in mind when we're kind of communicating this with the design teams, and also to understand that it's not their responsibility to design for us. It's part of the collaborative environment we're trying to create now, and what BIM is forcing us to do. As the last day, QR codes here. If your phones are there, just take a picture of those. It links to LinkedIn. But that's it from us today, and I can see time. We've about 8 minutes left, which is great. We'll have a few questions. James, perhaps you can have a look there on the chat. Anybody out there also has a question, raise your hand, or let's just jump in. Let's see if we can get a dialogue going for the last 8 minutes on this. And again, it can be about what ARM and the methods of measurements we're using, but interesting to hear your thoughts out there.
I think just to maybe start the ball rolling, Ross, I think there was a comment earlier from Jim around architects and the use of ICMS. Do you want to comment on that further?
Yeah, actually, Jim, that's a good one. So the question is well, do architects know that they're going to have to design in relation to ICMS? The answer to that is actually they're not going to design in relation to ICMS. There's some thoughts out there that we'll be able to map ICMS to Uniclass, and then with that coding structure, the design team will be able to allocate both Uniclass and ICMS when modeling. We don't think that that's possible, because what we're doing is we're adding another layer of responsibility to the design team that's probably not necessary. But the way we look at it is our ICMS structure is within our cost estimating platform, Qubit, ICMS, Costix, whatever. And then you're bringing in models in IFC and mapping it to ICMS. So your output is an ICMS format, but the design teams aren't. There's a debate going on at the moment about that, but Jim, please come in. Yeah.
Yeah, Ross, thanks very much indeed for another fine presentation, and Aidan as well, much appreciated. Just on the question of whether the architects are aware that they're going to have to eventually roll in with the ICMS standards.
Yeah.
I think clearly there's a role here for the liaison committee for the construction industry, because the RIAI are one of the constituent bodies. So that would be a perfect forum to drive the awareness of the ICMS amongst architects and other related disciplines.
And I think there's, I'd say, James, the SCSI and so on, there is these discussions going on at the moment with the other associations on this to bring in a more collaborative approach to how we approach the markets together. We of course have our legacy issues, as we all know, between disciplines and so on. But I think that this is the perfect moment in time for us to change now. But I would say, Jim, it's an important one. On a kind of a macro scale, industry-wide, we need to also understand how the architects and engineers are approaching these new requirements in terms of, you know, the RII have brought out their BIM guides. Technically, we should be reviewing those to understand how they're going to approach it. And we have our BIM guides for QSs. It would be good if the architects reviewed that. And I think that it's a key point that we need to really communicate a little better, I guess, horizontally across these disciplines.
Yeah, I mean, that's my point there. I mean, the key form, in my view, would be the liaison committee.
Yeah, agreed. Yeah.
Okay.
Thanks, Jim.
Thank you.
Anybody else got anything there?
There's a couple more in the chat, but I might just invite if anyone wants to unmute and ask a question. Okay, there's one in the chat there, Ross or Aidan. How many different discipline models are there?
I can take that, Aidan. It depends on the size of the project, I would say. The larger projects generally are broken up into multiple sub-disciplines because of just the size and nature of them. We're working on one or just finished one where I think we had somewhere in the region of 6 or 7 sub-discipline models, 25 buildings with 156 unfederated models. And when I mean unfederated, non-combined models on the projects if you were to split by building. So it depends on the project. The smaller projects, for example, the services would be modeled by one modeler perhaps, or even the entire engineering modeled by one modeler. So it really depends on project by project. I don't know what your experience is, Aidan. And then Jim, you have your hand up.
Yeah, something similar to that. Let's say commercial project at the moment now, we have a facade consultant who's doing the model. We have 2 separate models from the engineer, one for structures and one for civils. The architect has one single model, and then we have one model from the services consultant at the moment. That started out as 2 at the start for some reason, but was obviously federated at some point. Yeah. And again, a key point there that Ross made earlier on, don't ever measure structure from the architects. It's the first area you'll get caught in. The architect will have structure on his drawing, but it's a placeholder, for the want of a better word, to give context. But it's key, because maybe the slab is correct, but like your upstands won't be right, and different areas. It might be 95% there by the time you get to tender stage, but I wouldn't be relying on it. To be honest, if you get the models to 95% at tender stage, you'd be doing well. But not mind the architect's placeholders. But yeah, there's what I would say on that is sometimes you can get the architects maybe to bring where they have different disciplines under their wing. Let's say maybe like a facade consultant. It might be a case of that facade model is federated into the architect's model, and you can extract from there. But again, that's something you could get defined in your BEP or as part of your work process, as your workflow process, as Ross mentioned earlier.
Jim, your hand is up there.
Yeah, Ross, I'm just wondering, the various models from the different disciplines, does it end up in one single confederated model? Like in the traditional sense where the architect would be coordinating design. So notwithstanding what the structural or the building services have on their drawings, etc., in the traditional, old way of doing things, if you like, the architect would still be responsible for having you look over to make sure, listen, these set of drawings that are going out to tender, this represents the office block, full stop. So similarly with BIM, I would imagine there must be the single confederated model.
You have a design lead, so whether it's the architect or engineer, and it depends from a European perspective, it depends on who takes lead on the project. Traditionally, maybe, as you mentioned, Jim, it could be the architect. They would have responsibility for the delivery of quality design information. You might have a federated single model, but often you don't, because a federated model, it's too big to manage on the major projects. So it will always be unfederated. But clash detection, quality control, information quality, all of that technically is the responsibility of the contractual design lead, let's say the architect. But that being said, we all know what happens at the end of projects and the pressure the design teams are under. It's our responsibility to make sure we're getting the information we need. So I don't think in the last 8 to 10 years, I haven't seen a federated model. Initially, when we began 10 years ago in Denmark, it was federated, but the models were just way too big. So if you're jumping onto a project that's, 5,000-10,000 square meters or above, and they're going, we need a federated model, my advice would be don't. because it will become too big to process for the downstream, let's say at the QS, the contractor, the subcontractors, etc. And just to mention,
yeah, I have the same experience.
Sorry,
Federated flash detection. You wouldn't ever import it into your software for quantity takeoff. It would never drive it.
No, they're way too big. And just in relation to that last question, I would say you would have a minimum of probably 3 to 4 disciplines, and then you could easily have a maximum or a high level of 10 discipline models, depending on the size of the project. But you will for sure have architecture, structures, and services. And we always have services split in electrical and mechanical. And as you say, the civils could be one. So like 3 to 5 minimum, I would say, and then it can be up as far as 10 or more. Very good. Thanks for that, Aidan. He's after jumping off anyway. He had a call there at 12. We have hit the end, I guess, for this particular presentation. The ones to follow, we're focusing on the actual disciplines, so architecture, structures, and MEP. They're the last 3 bites to happen over the next 2 weeks. But yes, thanks everyone for today. Much appreciated. It's all from you, James, on your side.
Yeah, just to say thank you again to you, Ross. And I suppose just as we're coming towards the end of the program, just for everyone to have a think about any topics that you might like to cover in the BIM clinic that we're having as kind of a wrap up to everything. So if there's things you'd like to get a bit more of a deep dive or a bit of a conversation going on at that session, just start having to think about those as well. But other than that, just thank you everyone and have a great weekend.
Great. Thank you very much
everyone.
indeed. Much appreciated. Thank you.
Enjoy. Bye-bye.